Hey everybody, this is the Advanced Algebra Trig Pre-Calc video on graphs of the tangent, and this is going to be a review because we haven't done this for a little while, and I know that you do need to make sure that you can graph a tangent graph. So what I want to do is I want to just start with, this is my first one, I'm just going to start with the tangent graph and see what happens, and then we'll worry about transformation. So if you want to move on to example 2 because you know the tangent graph, you're okay. But what we did is that we took this unit circle, okay, and we took the quadrantal angles, which was at 1, 0, 0, 1, negative 1, 0, and then 0, negative 1. And what we did is we made this table of x's and y's. Now, for the tangent, we also need these points as well. So I'm going to leave points for that. So we're at 0. This is pi over 4 right there, and then we go to pi over 2. Here, this is 3 pi over 4. And we go to pi right there. And this is going to be 5 pi over 4. And down here, it's 3 pi over 2. And then right here, that's 7 pi over 4. And then we go all the way around, that's 2 pi. All right, so the way that we found the tangent, remember for this unit circle, all points x and y go cosine sine. Well, all the points for the tangent is going to be your y coordinate over your x. So we're going to go y over x as I go around here, and I'll use my green pen. So y over x, what's 0 over 1? That's 0. What's y over x, what's 1 over 0? That's undefined. Here, what is y over x with 0 divided by negative 1? That is 0. And here, y over x, what's negative 1 over 0? That's undefined. So this is the one where we had some asymptotes, right? So at 0, it's 0. And at pi over 2, it's undefined. And then over here, it's 0 at pi. 3 pi over 2, it's undefined. And then back at 2 pi, it's 0. All right, and I could go backwards. Then what I decided to do is that I needed to have those points, like right in here, I needed the pi over 4, 3 pi over 2, 3 pi over 4, 5 pi over 4, and 7 pi over 4. I needed those as well. And remember, those are the nice points. Make sure I'm straight. Remember, those are the nice points that had coordinates that were exactly the same, and that's the reason I use them, is because if I'm dividing y's and x's, why wouldn't I want to use those? So this guy was the square root of 2 over 2, square root of 2 over 2. This one's the square root of 2 over 2, square root of 2 over 2. Same thing, but we're going to make it to the left, so it's negative. This one is going to be the negative square root of 2 over 2, negative square root of 2 over 2. And here we're going to be at the square root of 2 over 2, negative square root of 2 over 2. So when I divide the y's and the x's here, these two are the same. It's going to be 1. When I divide the x's here, they're the same number but different signs. That's going to be negative 1. Because again, we're finding the tangent, y over x. Y over x here, they're the same and the same sign, so that's going to be 1. And y over x here, the negative square root of 2 over 2 divided by the positive square root of 2 over 2, that's going to be negative 1. So at those spots, I'm going to put these in here. All right, and here's my graph. All right, first thing I'm going to do is I'm going to say, okay, what's my period here, okay? So hopefully we'll remember what the period is, because the period of a tangent graph is different than the sine or the cosine. So here we go. I'm going to put pi over 2 would be here, and then negative pi over 2 would be there, all right? Here, let's go with, this is pi over 2, this would be pi, and this would be that one. Let's make this 2 pi. I know I'm getting into my table, I apologize. And then this would be, what, negative pi. And then I could actually go back here, and I won't get the other pi in there because I went a little too big. I got a little too happy. All right, where are my my zeros and my asymptotes? Pi over 2 is going to be between 0 and pi. 3 pi over 2 is going to be right here, right? And so it looks like if I look at between here, every pi, I'm going to have an asymptote, which means there's one here, and there's actually one here. All right? All right, and then the next thing I do is say, okay, my zeros, right? My zeros, 0, 0, right? Pi, the next one would be pi is going to be at 0. Next one, 2 pi is going to be at 0. I know that's over here. That means negative pi is also at 0. So then you got to figure out, how does everything go? If you look at the table, everything's at 1 or negative 1. So let's make this 1. Let's make this negative 1, and let's go for it. All right. So this is between 0 and 2 pi is pi over 4. Pi over 4, we're up at 1. Next, we're between pi over 2 and pi. Between pi over 2 and pi, we should be at negative 1. Between pi, and that's 3 pi over 2, so pi and 3 pi over 2, we should be back at 1. And then I have an asymptote, and then between that asymptote and 0, that'd be right here, we're going to be at negative 1. So this is kind of the key where you go and you're like, oh, I know what this is. right? Because this is up, that would be down. All right, and this would be up here, and that would be down at 1. I'm kind of off, but there you go. All right. So that's what that should look like, and I like to check my points. So this would be what, if this is going to be negative pi over 2, this would be negative 3 pi over 2, because I'm going to create a window that looks exactly the same. All right, mode, we're in radian, good. Here we go, get rid of this. My equation was what, just tangent of x. My window, I'm going to go from negative 3 pi over 2 to 2 pi. And sorry, I did not finish this off. It should be like this. It's going to be a half of 1. All right, so here we go. Negative 3 pi over 2 to 2 pi. My y min, it doesn't really matter what I do here. So here we go. I should have something that looks exactly like this when I press graph. So there's my first one right here, right? And there's my second one. And there's my third one. And then the tail end of my fourth one. So I'm feeling really good about that. So I have that. All right, looking at your test, it looks like I need to find the domain and range. Asymptotes and period. Okay, my domain is anything but these asymptotes. So x cannot be equal to, this asymptote's at pi over 2, so it can't be equal to pi over 2, plus or minus. Okay, how far is it away for us to get to the next asymptote? Well, it should make sense that if I'm going from pi over 2 to 3 pi over 2, wouldn't we go here to here? Isn't that a pi? So it's going to be plus or minus pi times n, and that's where n is an integer. All right, my range goes forever, negative infinity to infinity. My asymptotes, there they are. They're at vertical, so it's x equals pi over 2. Plus or minus, they're always pi away. Pi times n. Again, that's where n is an integer. I'll just keep that there. And the period is pi. The period for the tangent, you guys, is always pi. So if this is my b value right here, it's always going to be pi, over b is equal to our period here. Right? And that's what that looks like. The big thing here is to notice that the asymptotes are between negative pi over 2 and pi over 2. That's super duper important in these. All right, my next one. So that's basic one. I may be flipping back and forth with that one. Okay, here's my next one. Y equals 2/3 times the tangent of x. So here's what we're going to do. For 2/3, this is my vertical compression. So essentially, you guys, I'm going to use the same graph, but rather than going up 1 and down 1 in these spots, I'm going to go up 2/3. I'm going to compress those points in. All right. So everything else basically is staying the same. All right. So we had asymptotes here at pi over 2. Now I'm in negative pi over 2. And then this would be pi, right? And then that would be 3 pi over 2. And this would be 2 pi. I can do that. And same back here. So this would be negative pi, negative 3 pi over 2, and 2 pi. All right, and then thinking back at pi over 2, if you have to put this down, what's happening at 0 and pi over 2? At 0 or 1, 0. Y over x, 0 divided by 1 is 0. So here we start at 0. And at this one, it's 0, 1. Y over x, what's 1 over 0? That's undefined. So we know that at pi over 2 is undefined. Basically, it's what I did before. And every pi over 2, we're going to have a asymptote, right? All right, so then the next question is, okay, that 2/3, what does it do? Well, usually we go between those two angles, which would be like here and here, and we go up 1 or down 1 because we divided by those points, the square root of 2 over 2, square root of 2 over 2. And in this case, it would be the negative square root of 2 over 2, positive square root of 2 over 2. All right, and so we'd be at 1. Now this time, we're not at 1. We're at 2/3 because we're stretching it. So rather than going up 1, 2/3 would be maybe here. Rather than going down 1, 2/3 might be about there. Between these two, we usually rise to the right, but 2/3 would be about here. Down 2/3 would be about there. And here, we're just going to go down 2/3, about there. And then I'm going to go up 2/3 and down 2/3. And there we go. And sorry, I thought I had more time. All right. So we're going to cut this off right now. And we'll finish it off with this one. Good luck. That's the video, end of video 1.